class. This is part 2 of 15.2. So we are doing the second example in the packet for the 15.2 section. And then we are also going to look at the last page. After we're done with that, we'll just do 3 examples and then you'll be all set to finish up the packet. All right, so measure of angle 2 plus the measure of angle 3 is 180 degrees. That tells us these two angles add to 180, or they're supplementary, basically. And it also says that 2 and 5 are supplementary. So 2 plus 5 is 180, and 2 plus 3 is 180. Now, when I look at those, I say, well, okay, so if they're both sets of supplementary, then 2 and 3 are supplementary, 2 and 5 are supplementary, meaning that 3 and 5 are both supplementary to angle 2, then if they both have the difference between themselves and 2 to be 180, then of course you can use the congruent supplements theorem and state that because they're both supplementary to 2, 3 and 5 must be congruent. And if they're congruent, they're alternate interior angles, so our lines must be parallel, which is what we're trying to prove. So of course we're trying to prove that. We're going to use the alternate interior angles converse. Remember, it's the converse because they're parallel. So if you go back in your packet to the page on the theorems and their converses that we went through a minute ago, right here, then you can see alternate interior angles converse says that if two lines are cut so that alternate interior angles are congruent, then the lines are parallel, which is exactly what we're trying to prove. So we're going to state first that the measure of angle 2 plus the measure of angle 3 is 180 degrees, which is, of course, given. All right. And then from that, we state that because their sum is 180, then we know for sure that angles 2 and angle 3 are supplementary. And that's by definition of supplementary angles. All right, the next thing we have to state then are that angle 2 and angle 5 are supplementary because that's given. And then we can move along with the next statement, because both 3 and 5 are congruent or supplementary with angle 2, and because they're both supplementary with this to the same angle, they can only be one measure. And that means if they're only one measure, then they are congruent. So angle 3 must be congruent to angle 5, and that's by the congruent supplements theorem. And if they're both congruent, and they happen to be alternate interior angles here, then by the let's see, alternate interior angles converse theorem, then P must be parallel to Q. Okay, and that's that statement. Now we're going to move on to the last page. So if you'll just go to the last page in your packet, so that you're at number 10, where you're given Q and R parallel. Now this one becomes a little tricky, because if Q and R are parallel, we have to be careful to note that, well, I'm going to use some blue for parallel lines so far anyway in this section. So these two are our parallel lines. We can put a little arrow on them so it will remind us that those are the two parallel lines, because it's easy to think that P and T are parallel as they look parallel, but we're trying to prove P and T are parallel. So those will be what we'll be working on there. So if they're parallel, then each of these becomes a transversal, and that means 4 and 5 must be consecutive interior angles. And this also becomes a transversal, and with that being a transversal, then 6 and 7 are consecutive interior angles, and therefore their sum is 180. And then if we can substitute 5 in for 6 in the end, then we can state that these two, so we'll state 4 and 6 in the end have to be supplementary as well. And if they're supplementary and they're consecutive interior angles, then P and T must be parallel, all right? At this point, we don't know that for sure, but that's how we'll go about the proof. Remember, it's good to analyze and figure out what you're doing. So our first statement will be that that Q is parallel to R, our two blue lines, which is given. And then from that, we can state that angles 4 and 5, so these two, 4 and 5 are supplementary, as well as 6 and 7. All right, and that is the consecutive interior angles theorem that says that if two lines are parallel, then their consecutive interior angles must be supplementary. So consecutive interior angles theorem is what gives us that information. Now that we've gotten two sets of supplementary angles, we can state that angle 5 and angle 6 are congruent, which was our given. And from that, we can just substitute. And we can substitute angle 6 in right here with angle 5 right here. So we're going to rewrite this line with angle 6 substituted in for angle 5. So angle 4 and angle 6 are supplementary. And if that is the case, which it is, that's substitution. All right, and then if they're supplementary, 4 and 6 are supplementary, then they happen to be along the same transversal. The blue line now becomes a transversal for the green and yellow line, and therefore P must be parallel to T by that consecutive interior angles converse theorem. We use the converse again, remember, when lines are parallel. So consecutive interior angles converse theorem. All right, done. All right, last one. Now this one again, we're given some lines are parallel, NO and PS are parallel, and we're trying to prove OR and TZ are parallel. And we're also given a bit of information that angles 1 and 7 are congruent. So let's mark our NO and PS, they're right here with blue lines because those are parallel. All right, let's figure out what we're going to do here. We're trying to prove these are parallel, OR and TZ. So if they're parallel, we know 1 and 7 are congruent. So 1 and 7 are congruent. If we can use 1 and 3, they're corresponding angles that are attached to this transversal OR, the parallel lines. So 1 and 3 are congruent, and then we can state 3 and 7 are congruent by the fact that 1 and 3 are congruent and 1 and 7 are congruent. Then by the transitive property, 3 and 7 are congruent. And if they're congruent and they're corresponding angles, then R and Z have to be, or OR and TZ have to be parallel. So that's our idea. Great at you. Yay. Okay, so number 1, NO is parallel to PS, is given. And then number 2, from that, we can say that angles 1 and 3 are congruent because they are corresponding angles. We have a corresponding angles theorem, right? Corresponding angles theorem. I'm going to just bring this over here real quick. Corresponding angles theorem says that if two lines are parallel, cut by a transversal, then the corresponding angles are congruent. So we got that. And then we also know from our given that angle 1 and 7 are congruent. Again, that's given. And then the last thing we can state is because 3 and 7 are both congruent to the same angle 1, then 3 and 7 must be congruent by the transitive property. So angle 3 must be congruent to angle 7 by the transitive property of congruence. And then last but not least, because 3 and 7 are congruent, they are corresponding angles attached to the transversal P, stating that these two R and Z, OR and TZ must be parallel. So we're going to say that OR is parallel to TZ. Because they're corresponding angles, then if consecutive interior angles are supplementary, then the lines must be parallel, right? Apparently. Okay, so that's by, what were they, consecutive or corresponding? Corresponding angles, converse theorem. All right, so that completes all of the lessons in our parallel lines packet, which is really awesome. Now, if you printed off the whole packet, you'll note that at the end there were a bunch of labels that were supposed to be printed off on labels. If you can't print those off on labels or you don't have the labels, that's fine. You can just use them, print them off, use them, and cross them out as you finish up the packet. Those were meant to go in the packet for this homework that follows the first two examples I did. So 15.2, you can stick the labels on this little, all of these three, all of the examples in the homework. You can just stick those labels right in there, and you can just write them in and just cross them off as you use them. Or you can stop by the school, the math door outside of my room. The labels are already printed on labels for you, so you can pick those up if you prefer to do it that way and stick the labels in there. All right, and then once you're done with the whole packet, then you can scan it, either scan it or you can put it in pictures, take a bunch of pictures on your phone. And then there's a submit button up at the assignment on the right hand top corner. And you can just submit it there. And then I'll have a review up for you on Monday. I did set up a calendar so you can check and see what to do every day. And that might be a little more helpful. And starting to get everything all together. So good luck. Goodbye.